Okay, on problem number 1, it says we have the function f of x equals 400 times 0.5 over x over 80 models the amount of pounds of a particular radioactive material stored in a concrete vault, where x is the number of years since the material is put in the vault. Find the amount of radioactive material in the vault after 110 years, round to the nearest whole number. So this problem right here is just a substitution problem. So what we want to do is we want to go ahead and take 110 and we'll substitute it in place of x. So notice we've got 110 in place of our x value. Now it's just a matter of, after we substituted that in, to go ahead and just put it into our calculator and find out what the answer is. So if you just take your calculator and into our calculator, we just go ahead and type in, it says that we have 400. And we're going to take that times 0.5. So 0.5. And go ahead and hit your power key. And then go ahead and type in our 110 divided by 80. Hit enter, and it looks like that answer comes out to be 154.22. So there's our answer right there. So our answer looks like it's going to be 154. And if you look at your multiple choice, that's going to match with the answer of D, 154 pounds. Okay, on my next problem, on number 2, it says I want to use the graph of f of x equals 4 to the x to obtain the graph of g of x equals 4 to the x minus 2 minus 2. So you're going to remember that to graph this, a normal exponential graph has a main point of 0, 1. So since it has a main point of 0, 1, this is what my normal graph would look like. So I'd come up here to the point 0, 1, put a dot there, and my asymptote is going to be 1 below that. So even though I wouldn't be able to see it too well because it's on top of my x-axis, and then you're going to notice that since this is a 4, it is going to go up as you go left to right. So that is what the graph of f of x equals 4 to the x looks like. So now what I'm going to do is I'm going to go ahead and take my graph that I want to do right now, and I notice that that is 4 to the x minus 2 minus 2. So the first thing I need to do is I need to find the x shift. So here's the x shift right here. And remember, the x shift, all of your shifts happen by their roots or by their answers. So I'm going to take x minus 2, and I need to find that answer. So that answer, if I said equal to 0, is x equals 2. So the x shift is going to be 2. Now my y shift is right here, negative 2, and that is already in answer form. So here's my y shift of negative 2. And I'm going to go and add them together to find my new main point. So I take 0 plus 2 is 2. I take 1 plus negative 2 is going to be negative 1. And that's going to be my new main point of this graph. So I go to this point right here. I make a dot at 2, negative 1. The asymptote is going to be 1 below. So I put in my asymptote. And then since that is still the 4, I'm just going to go up as I go from left to right. And so that's what your graph of g of x equals 4 to the x minus 2 minus 2 would look like. On this next problem, on problem number 3, it says the size of the bear population at a national park increases at the rate of 5.1% per year. If the size of the current population is 128, find how many bears there should be in 4 years. If f of x equals 128, e to the 0.051 and round to the nearest whole number. So notice here's my equation right here. So my equation, I've got 128 e to the 0.051t. And I know through my study of exponential functions that this right here is always the original population, which matches up. It says that the original population was 128. And then it says that this right here is my rate. So even though my formula supplies that, So here's my current population. I just wanted to point that out to you to make sure that you remember that. So if you ever have to set up your own equations, you'll know how to set them up. So that first number is going to be the current population. And then your rate is your exponential. So to solve this, the question is, how many bears should there be in 4 years? So this is actually just a matter of substitution. So you're going to notice that in 4 years, that is t equals 4. So now it's just a matter of putting it into my calculator. So I take my calculator, and I'm just going to go ahead and type this in. So I've got 128. And then hit your E key. And then go ahead and type in 0.051. And then times that by 4. Hit enter, and it looks like it comes out to be 156.966. So we'll just go ahead and round that off to 157. So it looks like your multiple choice answer, looks like that answer would be C, 157. So looking at number 4. So number 4 says, use the compound interest formulas A equals P times 1 plus R over N to the NT and A equals PE to the RT to solve. So we want to go ahead and use our formulas. It says, find the accumulated value of an investment of $1,650 at 5% compounded monthly for 20 years. So here's a breakdown of our formula. So as I look at my formula, I know that this R is going to be my rate. I know that T is going to be my time, and that is my compounding rate. On this right here, this P is your principal or your amount that you are putting in. So this is your original amount. So when I look at this problem right here, I need to go ahead and substitute this in. And substituting in those numbers, it says my original amount that I invested was $1,650. So here's my $1,650 that I put in my formula. Okay, now I've got my 1 stays the same. So my rate, it says in my problem, is 5%. So don't forget to change your 5% to a decimal when you put it into your equation. So that's 0.05. So 0.05 would be my rate. And it says it's going to be compounded monthly. Well, compound monthly means that it's going to be compounded 12 times per year. So that's 12. So there's my compounding rate, is my N. And the time that I'm going to leave it for, it says it wants me to leave it for 20 years. So I substitute in my 20. So once I've done all that, now it's just a matter of making sure that I go ahead and put it into my calculator correctly. So putting it into my calculator, this is what it looked like when I put it in my calculator. So putting it into my calculator, let's see if I can slide this calculator over here so we can see our formula. Okay, so it says that I have 1650. And I'm going to need a parenthesis there. I've got 1 plus, I'm going to need parentheses around my 0.05. So put a parenthesis around 0.05. And then we're going to divide that by 12. And then we're going to need another end parenthesis. And then I'm going to take that all to the, so hit your power key. So then we've got 12 times 20. Once I'm done, hit enter. And it looks like my answer does come out to be $4,475.86. So that would be your answer. So your answer comes out to be $4,475.86. Looking at the next problem, now I'm going to use the other formula. So you're going to notice that on your test it'll list both formulas down. So it says we've got this other formula of A equals PE to the RT. So to solve this one, I have to remember that again, P is going to be my principal or my original amount. So So here's P. So that's your principal, also known as your original amount. So remember your R is going to be your rate, and T is your time. Now we just need to go ahead and substitute in the numbers correctly. So on number 5 it says, find the cumulative value of an investment of $7,000 at 7% compounded continuously for 3 years. So here's my P. My P is 7,000. So I substitute that in. E is that number that's in your calculator. That's the 2.7182, but your calculator will put that in for you. It says I've got 7% interest, so make sure you change that to decimal. That's going to be 0.07. And then we're going to go ahead and leave it in there for 3 years. So here's my 3 years that I'm leaving it here for. Okay, now that I've done that, I just go ahead and put it in my calculator and see what that comes out to be. So on my calculator, I'll slide this back over again, and we'll put it inside the calculator. So it says we've got 7,000. Hit your E key, and then type in 0.07, then times by 3. Hit enter, and that comes out to be $8,635, and we'll go ahead and round it off to 75 cents. So that would be my answer. So notice your multiple choice answer is going to be A, $8,635.75. Okay, on this next problem, on number 6, the problem says that it wants me to, it says write the equation in its equivalent exponential form. So remember to write an equation in exponential form. There's 2 ways you can do it. And since we've learned this other way, we could just base 2 both sides, which is what I do right here. I went ahead and base 2 both sides. And since 2 log base 2 is opposites, that means I get 4 equals 2 to the x. So that's how we did it later on in the chapter. Earlier in the chapter, we learned that if you just want to go from a logarithm to an exponential, you keep the same base. So here's my base, which is 2. And then you switch the x and the y, which is the definition of what the logarithm is to exponential. So I just switch the x and y, so then I get 2 to the x, all equals 4. So there's 2 ways to do this one. You can use the old rules that we learned at the very first of our chapter, which is said keep the same base, switch the x and y value, or since we learned later on when we were solving them that you could just base both sides by 2, which is what I did right here, you'll get the exact same answer. So either way works. Just go ahead and choose whichever method you want to do. So it looks like this one is going to match up with answer B. Okay, number 7. Number 7, it says write the equation in its equivalent logarithmic form. So again, there's 2 ways that you can do this one. So again, if you want to, you can do it the way we did later in the chapter, which we found out later in the chapter when we were solving them, that the opposite of a base 10 is log 10. So I can log 10 both sides. And when I do that, notice it's the opposite of a base 10, so those are going to cross out. So you just end up with 3 all equals log base 10 of y. So we can do that directly. That's how we're going to do it later on in the chapter. Earlier in the chapter, we learned the rules for changing into logarithms. So just write the word log. Your base becomes your subscript. And then you switch your x and your y values. So switching those x and the y values, I got log base 10. And then switching that over, so that'd be log base 10 of y, all equals 3. Either way that you want to do it, you can do it using the rules that we learned earlier in the chapter, or later in the chapter, just do its opposite, and you'll get the exact same answer. So it looks like my answer is log base 10 of y, all equals 3. So that answer matches with A. Okay, looking at number 8. Number 8 says, evaluate the expression. it wants me to find out what log base 2 of 4 is equal to. So remember, this means 2 to what power is 4. So if you think to yourself, 2 to what power is 4, so that answer would be 2. So you can use that right there and just solve it in your head. 2 to what power is 4, so that answer is 2. Another way you can solve this one, if you can't remember that 2 to the second power is 4, is that we could also use our change of base formula. So the change of base formula, if you want to use our calculator, just says that log base 2 of 4 is equal to log 4 divided by log 2. So once I know that, just go ahead and type that into my calculator. So typing that into my calculator, so I got log 4 turn my calculator back on here. Looks like it shut off on me. Okay, so I got log 4 divided by log 2. And that answer comes out to be 2. So let me slide this over a little bit so we can see what our original problem was. So here was our original problem, log base 2 of 4. So remember, with your change of base formula, you're just going to type it in as log 4 all over log 2. And your answer comes out to be 2. So going on to the next problem, it says that I have number 9, log base 3 of the cube root of 3. Now, we're going to go ahead and change that, the square root of 3. So it's log base 3 of the square root of 3. So remember, the square root is actually half power. So our first step, we're going to change this square root sign to a half power. Once we've changed that to half power, now we know that log base 3 and base 3 are opposites of each other, so they're going to cross out. And your answer is just 1/2. On this next problem, on number 10, number 10 says, use the graph of log base 3 of x to obtain the graph of log of f of x equals log base 3 of x plus 1. So just over here, I'm going to go ahead and just remind myself what a normal logarithmic graph is. So right over here, I'm going to go ahead and graph f of x equals log base 3 of x. So remember, this is your basic logarithmic graph. So if you remember right, on your exponential graph, the main point was at 0, 1. So since a logarithm and an exponential are inverses of each other, they literally switch their x and their y value. So switching this x and this y value means the main point of a logarithmic graph is 1, 0. So I come to my graph and make a point here at 1, 0. The asymptote is going to sit behind it, or sorry, to the left of it by 1. And then my graph just looks like this, and that's a basic logarithmic graph. Now to actually graph this new equation, so I got f of x equals log base 3 of x plus 1. You're going to notice that here's my x shift, my horizontal shift. And so this is, answer is -1. So I got to put my -1 there. So here's my main point. Notice if it did have its y value shift, it'd be right here. There's no number right there. So that means that there must be a 0. So here's my 0 right there. So now I'm going to add those two together. And here's my new main point, 0, 0. So to graph my equation, f of x equals log base 3 of x plus 1, I'm going to go ahead and make my main point right here 0, 0. My asymptote is sitting 1 behind it. So I'll kind of try and put it in here a little bit. Sometimes it doesn't work too well with this annotator. And then I just go ahead and draw in my graph. And that's what it'll look like. So that is the graph of f of x equals log base 3 of x plus 1. So don't forget, asymptote is 1 to the left of your main point. Okay, on number 11, it just says it wants me to go ahead and says use properties of logarithms to expand the logarithmic expression as much as possible, or possible evaluate the logarithmic expression without using a calculator. Okay, so first off, I just need to remember the rules for logarithms, for the logarithmic expansion. So here's the rules I've written down. Multiplication means addition, division means subtraction, and your exponents, they're going to go out in, it looks like I forgot to cross my T, so they're going to go out in front. So remember those rules. So here I've got my logarithmic equation, logarithmic expression. I've got log base 4, and then in parentheses I've got x to the 4th divided by y to the 6th. So the first thing I notice is there's my division. So division means subtraction. So I'm going to rewrite this as log base 4 of x to the 4th minus log base 4 of y to the 6th. Now, following my second rule here, exponents go out in front. So here's an exponent I need to put down in front. So that's going to give me 4 log base 4 of x. Here's my other exponent. It's going to go out in front. So that's going to be minus 6 log base 4 of y. So that's going to be my answer. Here's 4 log base 4 of x minus 6 log base 4 of y. Okay, on this number 12, it says use the properties of logarithms to condense the logarithmic expression. And then it also says write the expression as a single logarithm where possible. Evaluate the logarithmic expression. So notice, I need to remember this rule. It says write the word log or ln once and follow the above rules. So the above rules just going in the opposite direction. I know that subtraction is going to mean division. And I know the numbers out front become my exponents. So notice here is subtraction. So those become my division. And then this exponent, this number out front becomes the exponent. So you're going to actually see the answer written two ways. I don't care which way you write it, but if it is multiple choice, you'll need to be able to recognize that this answer, which is the ln of x to the 7th, y to the 1/3, or this answer are the exact same thing. 1/3 power is the cube root of y. So keep that in mind. And notice, make sure you only write that one time only. So notice I did write the ln one time only. And so that is how you condense your logarithm. On number 13, I've got log base 10 of 29. And the directions on number 13 just says use common logarithms or natural logarithms of calculator to evaluate to 4 decimal places. So log base 10 of 29, your change of base formula. The change of base formula just says you take the log of what's on top, divide by the log of what's on bottom. And so log base 10 of 29 is going to become log 29 divided by log 10. And notice also if you want to use the ln, it would be the exact same thing. It would be the ln of 29 divided by the ln of 10. Now once you have that, all you have to do is just put it into your calculator. So taking this problem, typing it into my calculator. Just type in, I've got the log, and put in 29. Divide by log 10. Hit enter. And it looks like your answer does come out to be 1.462397998. And that matches up with A. And A says that we have 1.4624. Okay, on problem number 14, it says it wants us to solve the exponential equation. So you notice we got e to the x plus 5 all equals 2. So remember we need to do the opposite to solve our exponential equations. So the opposite of an e is going to be the ln. So notice I took the ln of both sides. Opposite of e is ln. Now when I do that, the l and e are, since they're opposites, they're going to go ahead and cross out. So notice the l and e crosses out. I'm just left with my x plus 5, and that's going to be equal to ln of 2. So So once I get that done, I just go ahead and subtract my 5 from both sides. And I get x all equals the element of 2 minus 5. And then you can go ahead and put that into your calculator. So putting that into the calculator, just take a calculator, type in, turn it on here. We've got the ln of 2, I'll take the ln of 2, and then minus 5. It equals, and the answer is negative 4.3068. And that would be your answer. Look at this next problem. So number 15, another exponential equation. This one says that we've got 3 to the x plus 7 all equals 5. So remember to go ahead and solve a base 3. We're going to do its opposite. So the opposite of a base 3 is going to be log base 3. So I'm going to log base 3 both sides of my equation. And when I do that, I'm going to notice that this log base 3 cancels out. I'm just going to be left with x plus 7. Now to solve this part of the equation on the right-hand side, log base 3 of 5, I'm going to need to use my change of base formula. My change of base formula just says I take the log of the top number, which is 5, divided by the log of the bottom number, which is 3. So I've got x plus 7 equals log base, or log 5, divided by log 3. And then I'm just going to go ahead and subtract 7 from both sides. So subtracting 7 from both sides, I get x equals log base 5 divided by log 3, or sorry, log 5 divided by log 3, subtract 7. So now you just take your calculator to solve this. So taking your calculator, we're going to type in log 5. And we're going to divide that by log 3. And then once we get that answer, we're going to go ahead and subtract 7 from it. And that comes out to be negative 5.535. And that would be your answer. On this next problem, on number 16, here I've got a logarithmic equation on number 16. It says solve the logarithmic equation. I got log base 2 of x minus 1 all equals 3. So to solve this, I just need to remember that the opposite of a log base 2 is I'm going to base 2 both sides. So I base 2 both sides. This is also called exponentiating. In other words, this log base 2 of x minus 1 becomes my exponent, and this 3 becomes my exponent. So remember what you do to one side of the equation, you have to do to the other. Now I can go ahead and solve this, because these are opposites of each other. They're going to cross out. I'm just left with x minus 1. And then, of course, 2 to the third is going to give me 8 for my answer. So now finishing this equation off, I'm just going to go ahead and add 1 to both sides. So adding 1 to both sides, I get my answer of 9. And that matches A. On my next problem, on number 17, I've got another logarithmic equation. It says I have 5 times the element of 6x, but L equals 45. So to solve this, I'm going to do my algebra first. Doing my algebra means I need to go ahead and divide both sides by 5. So dividing both sides by 5, that's going to leave me with just the element of 6x, all equals 9. Now I need to go ahead and get rid of my ln. So the opposite of an ln is a base e. So that's my next step. I'm going to base e both sides, because that's the opposite of the ln. Now that I've based e both sides, that's going to cross out. I'm just going to be left with 6x, all equals e to the 9th. Now to finish off this problem, I'm just going to go ahead and divide both sides by 6. And when we divide both sides by 6, I get e to the 9th all over 6. And then I'm just going to take my calculator, type that into my calculator, and find that decimal answer. So on my calculator here, hit your E key, so hit second function. Remember, E is above the ln. Type in 9 for your power, and go ahead and divide that by 6. Hit enter, and your answer comes out to be 1,315.51. On my next problem, number 18, the problem says the formula A equals 260 e to the 0.045t models the population of a particular city in thousands t years after 1998. When will the population of the city reach 427,000? So notice, as you look at your equation, you can kind of look at it and see this is our starting population right here. So our starting population is, that scrolled up on me, let me go ahead and scroll back down again. So on number 18, here's our starting population of 260,000. This is the growth rate, 0.045. And now the question says, when will the population reach 427,000? So that's going to go place in my A. And it's already 1,000, so I got 427 equals 260 e to the 0.045t. Now all I got to do is just go ahead and solve this. So remember, when you're solving your exponential equations, make sure to just take care of your algebra first. So we want to divide both sides by 260. So notice dividing both sides by 260, this leaves me with 427 divided by 260 equals e to the 0.045. Now my next step is taking this, and I'm going to take my calculator, and I'm going to go ahead and divide 427 by 260. When I divide 427 divided by 260, it comes out to be 1.6423. I've got 1.6423, all equals e to the 0.045t. Now to get rid of this e, so remember our objective is to solve for t, so that's what we're trying to do, is we're trying to get t by itself. So to do that, we need to go ahead and do the opposite of e. So the opposite of e is the ln, so notice I ln both sides, and that's going to cross this out. So I'm going to end up with the ln of 1.6423 all equals, and we'll just scroll this up here, 0.45t. Now I'm going to go ahead and divide both sides by 0.045. So here's my answer for t, is just the ln of 1.6423 all divided by 0.045. So I put that in my calculator, see what that answer is going to come out to be. So putting this in my calculator, type in, it's your ln key, type in 1.6423, and then we're going to divide that by 0.045. And when I do that, I get 11.024393. So notice that that is not the answer though. So as I look at my equation right here, I have to remember that my answer came out to be 11. So here's my answer, 11 years. But it wants to know what years. The question says, when will the population of the city reach 427,000? So my original population was 1998. So now I have to add 11 to it, and that comes out to be 2009. That answer is B. On this next problem, on number 19, question says the value of a particular investment follows a pattern of exponential growth. In the year 2000, you invested money in a money market account. The value of your investment 2 years after 2000 given by the exponential growth model A equals 7,700. E to the 0.052t, when will the account be worth $12,952? So I'm going to take my 12,952, I'm going to substitute it in place of A, and then I'm just going to go ahead and solve this equation. So to solve this equation, first thing I do is I need to take care of my algebra. So notice this is 7,700 times E. So opposite of times is going to be divided. So we're going to divide both sides by 7,700. So when I do that, I get 12,952 divided by 7,700 equals e to the 0.052t. And I'm going to take my calculator, and I'm going to go ahead and find out what 12,952 divided by 7,700 is. That comes out to be 1.682. So now I'm left with my equation. I have 1.6821, rounding it off, all equals e to 0.052t. Now that I have that, I'm ready to go ahead and continue solving my equation. So to solve my equation, so scrolling this on down, we're going to go ahead and do the opposite of e. So remember, the opposite of e is ln. I'm going to ln both sides of my equation. That makes it possible. Ln and e are opposites of each other, so that's going to cross out. I'm left with the ln of 1.6821 equals 0.052t. Now dividing both sides by 0.052, I get the ln of 1.6821 divided by 0.052 equals t. Now I'm just going to go ahead and type that into my calculator. Typing that into my calculator, I've got the ln, and then I've got 1.6821. And I'm going to go ahead and divide that by 0.052. That comes out to be t is equal to 10. But notice my question is, when will the account be worth $12,952? Well, my starting point was the year 2000. So I'm going to add 10 to it. And so that answer will be the year 2010. So that answer is C. On my last problem, on number 20. Number 20 says the logistic growth function f of t equals 520 over 1 plus 7.7 e to the negative 0.27t describes the population of a species of butterflies t months after they're introduced to a non-threatening habitat. How many butterflies were initially introduced to the habitat? So to solve this problem, you're going to notice that whenever anything is happening initially, that means that in my equation, here's my t equation, that means that t is going to equal 0. So that's your initial introduction. So it's just a matter of actually substituting 0 in place of t, and then actually just going ahead and solving that equation. So once I've substituted in the 0, I'm going to go ahead and just put it in my calculator. So putting this in my calculator, that says I got 520, and then divide by, and always make sure you put parentheses around your denominator. So put a set of parentheses, and it says we got 1, and we got plus, we got 7.7. That's my decimal point there, so 7.7. Hit your E key, and then take that to the negative 0.027 times 0. I actually didn't need to type that in because I know that anything times 0 is 0, so I could have just put in the 0 up there. In parentheses, and hit enter, and it looks like it comes out to be 59.77. So go ahead and round that answer off to 60, and that looks like that matches my equation D.